Right, so now I've moved on to the power amplifier card. I haven't powered this up yet, so I don't mind touching it. Right. It's got like 300 volts DC and stuff like that on it, so if you ever work on this particular card, be very careful around all the terminals on the back here, on the extenders and on the actual card itself, because if you touch the wrong thing it can kill you. So it's like, be very careful around this. There are voltages across this board on the back here as well, so again, be careful around there. I probably haven't mentioned this enough in the other videos about just being careful about what you're touching, because there are high voltages in some places on some cards, not necessarily all the cards, but this one here definitely has high voltage on it, so you have to be really careful. Now what I'm going to do is just go through and do some voltage checks. I haven't done any testing on this card yet. I'm going through the testing procedure. I've done like component level testing and didn't find anything obvious. But there's some old electrolytic caps on here, so I'm thinking that these should be replaced. I've got some 330s here. There's a 3UF there, sorry, there's a 3UF. These are 330, that's a 330, and this is a 22UF. So those are prime candidates for replacement. So that's something I'll be considering doing, certainly, is just replacing these caps. But first let's go through troubleshooting and see if I find anything before I change those parts. I did do some testing on it. I think they tested okay, but I don't trust them anyway. I might as well just replace them. I've got the parts here. So I might as well just get on with this and see how we go. It's got a few relays on here. Well, two relays here, that's a cap over there. And these two are switching for the levels. I think it does, was it 3 times and 30 times multiplication of the power input from the oscillator card, something like that anyway. So the testing procedure asks you to set this up, unplug the oscillator card, which I've done, set this bias switch here to the white dot is showing, and testing for a bias on the connectors here. So I haven't actually tested at bias. I probably should test for that first, even though I know normally I'm getting a I think it's about 27 volts DC. Is it negative 27 volts? Something like that. On those terminals at all modes. In a 100 volt mode I'm getting like minus 140 odd volts. So DC. So I know there's definitely a fault. So I'm inclined to just skip that step because I know it's wrong anyway. So I might just go through and test the voltages going into the card and just work through the whole testing procedure, which is in the manual. That's the plan, and we'll see how we go with this. I've replaced the fan. I put a new fan in it because the other one was so noisy, it was just driving me nuts with rattling around and stuff. So I put a new 240 volt fan in there. The original fan is a 115 volt fan. So what I actually had to do is rewire the fan supply. Now the wiring, I don't know, see it on camera over there. You might not be able to see it. No, there's cards in the way. But there's some wiring over here, the connector, and I've done some rewiring in here. I might show that later on once I've got this card out of the way, or move the camera or something like that. Okay. Basically the fan goes between a white and black wire. The two closest to this side, there's a white wire, and then a black wire, a green wire, and another black wire. The white wire and the black wire on this side normally go to the fan. But again, it's 115 volt output. It goes through the transformer winding, so whatever voltage you got set up on it, it will output that 115 volts to the fan. What I've had to do is on the black wire is I've cut that off, and I've then spliced it onto the other black wire. Okay, because in my case that's 240 volts. In this situation it works fine. Really, if I was doing this properly, I'd actually run it onto a different tap on the transformer itself. So I'd actually hook it onto that transformer directly, rewire the taps or something on there to actually run straight to that fan. So again, if you change the voltages, the fan gets the correct voltage. So instead of running a 115 volt tap, it run off a 240 volt tap. All right. That's what I should do, but I haven't done that. I thought, well, this is good enough. I mean, it's 240 volt. It's not going to be going out the country anytime soon. If it does go out the country and goes overseas, it's going to run at a lower voltage, which means the fan will just run slower. All right. It may not matter. All right. I think it's a more efficient fan, to be honest. So, well, we'll see how we go. So I'm going to pause this one out, and then I'll probably do some testing off camera first, and then just to get to see what I've got to do. Then I'll come back and record it and do it again. So I've got the ground wire hooked up to pin 17 as per the manual, and I've got to measure pin 21, the 13 and 19 on this side, which are a little bit awkward to get to, but I can get in there. And also got to do pin 16 on this side, which I don't actually have a test point on, but I can still touch onto it. Alright, so I just need to verify those are okay, and then we'll go from there and see what voltage we get. So I should hook on. I'll just touch it on pin 21. I'll just turn it on, see what we get, and then I'll go to the next one, so on. So it is high voltage. I don't want to be messing around too much in here. But being DC means there are smoothing capacitors in there which also have to discharge, so they are going to be still charged and slowly dissipating power. So even if once you got it turned off, there's still going to be power there, so you have to be careful of that. Okay. Right, so that is on pin 17, so I want pin 19 and 21. So I'll do 21 first, which is right there. Just rest it on that pin. I'm not touching the heatsink in case that's live, because I don't know. Right, 314 volts, 315 volts, let's say. Okay, and that's pin 21. That's supposed to be between 295 and 355. So yeah, that's okay. It's towards the middle of the range. Let's move this down a bit in case you can't hear me very well. Get slightly closer. Alright, so pin 19, which is right there. Again, not touching anything else apart from the chassis. 257 volts. As you can see there, look, I've turned it off and the power's slowly dissipating down. So, and the same for, I don't know, this pretty quickly, but this one here is dropping really slowly. So 21 dips really slowly, and 19 goes down quite quickly. Is that 19 one? Yeah, there's a 19, which is interesting. What did I say it was? 200 and something. 245 was it? 258. Okay, I'm getting a bit sidetracked now. So that is supposed to be 220 and 280 volts. So yeah, that's fine. That's in the middle of the range. That's absolutely fine. The next one I've got to do is pin 13, which is I'm actually doing these out of sequence because of the sequence the pins are in. Just making it easy to get to each one. Again, not touching anything apart from the pin and the chassis. I can make sure my fingers aren't touching anything there. Alright. Now, ideally get in a little clip lead and clip it on, but again it's a bit awkward in that little space to get to it, so this is just the easiest way of doing it. This is pin 13, which should be between minus 300 and, well, minus 295, minus 355. So minus 334. So again, no problem. So that's, let's say it was 334. Hold on. Look again now. Yeah, 332 that time. So yes, fine. It's again in the middle of the range. So they're all pretty well centered actually. So I need to check pin 16 on this side, which is, we've got one on pin 18. I've just been putting pins on these terminals each time I've been testing each section. So that's minus 251, and I should be getting between minus 220 and minus 280 again, so middle of range. So that section of power supplies are working well. Okay, so I've transferred the 0 volt or negative probe onto pin 86 on the card. Again, there's still going to be potential voltages here which are dangerous, so I'm going to still be careful about what I'm touching. Now I need to check on pin 76, 74, 77, 79 and 83 for correct voltages. Okay, so which will start over here. Let's turn this on. So this is first pin 76, 30 volts, 0.1. That just changes range. Just give you more accuracy there. Okay, so 30.15 volts. It's supposed to be between 29 and 31, so it's basically bang on, that's fine. Now I want 74 for between minus 29 and minus 31. Yeah, that's 30 volts, or minus 30 volts, that's bang on. So pin 77 for minus 15 volts, so it should be between minus 14 and minus 16. On 77, which is just there, so minus 15.55. So that's fine, it's slightly on the lower side but within spec. And then I've got to do minus, so we'll do plus 15 volts on pin 79, which is that on there. Alright, so yeah, that's 14.98. So yeah, that's basically in spec. It's supposed to be between 14.9 and 15.1, so that's fine. And pin 83 for plus 5 volts, which is between 4.75 and 5.25. 83 is actually just here. I don't actually have a test point on this one, so I'll just get down a bit lower and have a good look and probe it carefully. So just there, 4.96, so that's well within spec as well. Right, so that's all those voltages there. Also check out okay. Now there's a note here about pin 79 voltage at plus 15 volt being adjusted to suit the 185 volt supply. If that supply is a bit low, that 15 volt gets adjusted in order to bring that 185 volt supply up a little bit, if necessary. That's later on in the procedure for 185 volts, so I won't know until I get that through that far. So at least at this point all the voltage check out okay, so at least I know the supplies going to this card are all good. Although I already believe they were anyway. Okay, so now I've got the test point hooked up to TP6, which is the low range. Well, 0 volt, well, the negative on the meter. I really should find out what terminology I should be using for that. I don't know, the black wire. Alright. So I've got a measure on TP1 for minus 190 volts. It's got to be between minus 180 and minus 200. And then I also got a test on TP2, which is interesting. Hold on, am I skipping a bit there? Okay. There's a minus 190 volt limit voltage, but it must be between minus 180 and minus 200, so same voltages again. Okay, so I've got to test TP1 and TP2 for the minus 190. So TP1 is there and TP2 is there. Okay, so I hope you can see that in the camera okay. Think so. Right. Let's measure. Turn it on. TP1. Minus 192. It's creeping up slightly. TP2. Minus 192 also. So they all seem, well, they're in spec anyway, so that's good. Now I just just scroll this page down so I can see the next bit. Okay, so this C35, which I have to measure, it says I have to measure at the top of C35 for minus 190 volts, right? So it's between minus 180 and minus 200 again. Now, because this board is upside down compared to what is actually in the manual, it's actually the bottom, right? They seem to have it so you're facing the other side when you got, I don't know. Anyway, maybe it's just with this extender. I don't know. Maybe the factory extender goes opposite direction, so therefore it is in the right direction. I don't know. Anyway, so I need to measure on there for minus 190 volts. Yep, minus 192. That's in spec. That's absolutely fine. So let's look at the next part. So I'll go between R72 and the collectors of Q6 and Q8. So I've got to find those now. So here's the actual layout. just here. Alright, so what's I need? I need R72, Q6, Q8. This could take a little while. I'll come back. Okay, so I found R72, it's over here, and Q6 and Q8 are over here. Alright, so junction of R72 and Q6, Q8 collectors. I don't know which leg the collectors are. Yeah, maybe it's marked on the board somewhere. Let's have a look. So, R72 is actually marked on the board, and Q6 and Q8 are there, and I don't see where they join together. Maybe I can see two tracks going together there, so maybe that's a collector. So we'll have a look and we'll see what we find. So it's got to be between -20 and -20 volts. It's -21, which is fine. Let's check on R72 as well. Hit -21. Both sides. No issue there at all. Okay, the next step is step 37. And this is to check the plus 190 volt supply. It's got between plus 185 and plus 200. And this is at TP3. Where's TP3? TP3 right there. Okay, let's test that. Hope I'm not enough. The meter, hopefully not. Okay. There you go, 189 volts. Looks fine. No issue there. Okay, so the next step is step 41, jumps to. And I've got to check the DC offset between the output and TP6. So I'm still on TP6 here, so output is right here. 0 volts. So it should be a very low reading. Microvolts. It should be 0 volts plus or minus microvolts. I'm getting millivolts here. If I just make sure the zeroing is okay. Yes, it is. So there is a slight offset there. Why there's an offset there, I don't know. It's supposed to be. Where have we gone? So 0 plus or minus 100 microvolts. Well, yeah, it's not got that, is it? So I need to look into that part of it. So that's the first thing which hasn't quite gone to plan so far. So the manual says to adjust R6 here, which is something I already did, but in the setup I forgot to mention it. You have to wind this all the way counterclockwise. And that's where it is right now. If I then wind it clockwise, the offset is going up in value. So it cannot actually be reduced any further. So that could be an issue in this part of the circuit here. So I need to look into that, because it does seem like there's an issue there. Alright, so it seems that after working on the power amplifier card, I replaced 3 capacitors. These 3 here, the 330s and a 22. I couldn't replace the 3s because I don't have anything suitable. The 3s? No, 3. Yeah, the 3s, but they're high voltage ones. So I've got nothing suitable because they're really high voltage capacitors. So I'm going to have to look into doing those as well. But after doing that, even though these capacitors I took out to test okay, I actually now have voltage output. So let's fire this up. We have to wait for it to come on. Let's just chuck this across here to try and get some of the noise down. Will help slightly. Come on, hurry up. It's got a 30-second delay. There we go. Right, I'll turn it on. So I'm set at 1 volt right now. Hopefully you can see that. And I'm getting 400 millivolts or so. But it depends on the frequency. If I go to 1 kilohertz, it's a lot closer. 10 kilohertz, yeah, it's close-ish. Alright, it's actually really close there. 100 kilohertz, it actually goes over. Right, 1 megahertz. Yeah, I don't know how that's going to go as far as frequency coverage, but it seems to be working. So I'll slip back on 1 kilohertz again, and if I was to go through the voltage ranges, so it's currently 1 volt, it's 100 millivolts. Set to 1 volt, 1 millivolt. Yeah, 1 millivolt there. Get it right. The switch is a little bit flaky, just there. So there you go. 100 millivolts is now correct. Getting 84. 10 millivolts, getting 8.7. 1 millivolt, and getting 1.2. So it is actually doing those voltages. So we've got a 10 volt range. 10 volts again, 8 out. 100 volts is very wrong. It's about 13 or so. It's flaking around a bit, so it's still got an issue there. But it is actually doing something now, which is a lot more than it was doing before. If I stick it, say, back on, say 50 Hertz, which I know this meter can definitely measure. I mean, you can see this voltage is a long way out from what it should be, but it is actually doing something. It's just wrong. So yeah, it's some progress at least. Half a volt, yeah, say half a kilohertz. Yeah, I mean, it's doing something. It's like it's maxed out. So it's like maybe still be an issue with the feedback or something there. Let's fix this switch. So it's not actually dropping down, but it's doing something. Alright, so at least each range is now working, so that's a step in the right direction. Alright, so I've this adjustment just here on the oscillator control board. That's when I'd adjusted before to actually get the oscillator to work, because it was turned right down. And what I found, by turning it all the way up, I got the oscillator working. But it also works here and there, as you turn it down. So what I've found is, before, when I was turning these adjustments here to reduce the voltage, nothing was happening. And that's because this pot here was turned all the way up in order to get the oscillator working. As you can see, that then maxes it out. So I think this is like a balance control. If I turn it down, then I can actually get it under control. And it then steps up for the voltages. They're not right, but it is actually changing correctly. But it's topping out. Each range is topping out. So I think the drive voltage from, I think it's from here, is too low. So when I was doing my testing, I found this voltage here was half as much as it should have been. So I think that's the issue here. When I had it unplugged, it was okay. When I plugged it in, it dropped to about half as much. And I think that was incorrect. So I believe I've still got an issue here with this cable here. You see, from the reference, not being able to drive the correct load, or this is being overloaded in this end somehow. And I think that's why I can't get the correct voltage on here, because it's just can't drive enough voltage into the AC card as a reference. Without the correct reference voltage, it can't adjust the output correctly. I think it's got the incorrect output voltage. I have to measure it and confirm that, but it does actually step up now. So that's maxed out there. So 0.7 is about the most I can get, regardless of frequency, pretty much. Right, so it kind of tops out there, and it's not really reliable. So it depends on frequency, but it's at least now, when I do this, I can actually get it to change downwards. It's not right, but it does change. So I've still got some more issues here, but it is at least now alive. So the overload indicator, that's no longer on, that's off now, like it should be. So you know, it's, I don't know, what would you say, 70% there. You know, it now has an output. It's wrong, but it has an output, and it's changing. So definitely some progress has been made. This switch here is a bit flaky. I need to try and figure out what's going on with that. Don't seem to quite make properly. But yeah, anyway, it is working, but just not completely correctly. You know, the voltages are coming out wrong, they're not stable. So it could even be the capacitors in the main power supply over here on the right. It might be too much ripple coming out. I have replaced a capacitor in there, but we might need all of them replaced just to make sure that our power supply rock solid. That may be part of the problem, but I believe this is an issue here, so I'm going to look at this first and see if I can at least get this voltage here correct. But anyway, yeah, it's alive. That's something. So I've realised something with this. Now, when I had it working before, it's with the switch here was still in the bias setting adjustment position. So what that does is instead of having 190 volts going to the output stage here, it does plus or minus 30 volts instead. And say that was working. But that's why I wouldn't get the high voltage output on the 100 volt range, because there wasn't 100 volts possible because of the setting on here, because it's only getting plus or minus 30 volts. So but the overload indicator wasn't on and the issues weren't present. So but as soon as I put it back to its position it's supposed to be in, then I'm getting the issue with the no output and big DC bias on the output and that sort of thing. So that gives me a clue that, I mean, the output stage is working, but when I put a high voltage into it, it breaks down, which means it's probably a part which is breaking down under high voltage. And in fact there's a negative DC bias, means it's probably the negative rail side parts which are breaking down. So I'll need to go through and test all these parts, or possibly just replace things. It's in this section here, and this section had been worked on. There was solder flux and it's just a mess inside here. So someone's been working on this bit previously, and also they couldn't figure out what was going on. So I need to look at this as well. So this part here looks like it's been replaced. That doesn't look original. So maybe that's a bit of a key there about what's going on. And that is Q22, is it? Q22. And that is the negative side. Alright, so that's the negative side, that's the positive side there. So yes, there's definitely, you know, some clues here about what's going on, but I'm suspecting that there's a diode breaking down or something like that, or capacitor breaking down. You've got these tantalums in here; they all measured okay. Usually, if a tantalum goes, it just goes permanently. That's it, bang, they go. So I don't think it's going to be one of those. But two of those are in the feedback circuits of each side, one for positive side, one for negative side. And one's across the bias adjustment here to help smooth out the supply and the bias. So the bias adjustment is interesting as well. It doesn't seem quite right, so it's fully one end to get it correct. But there's other stuff going on too, I think. So what I'm thinking I need to do is try and identify some of these diodes and see if I can just replace them to eliminate the diodes. But I'm leaning more towards a breaking down transistor, because, you know, the low voltage works, but as soon as you put high voltage in, it's locking on. I think that's what's happening, and I think it's one of these negative side ones. I think it's one of these. Q23 just there. Let's have a look at that. Where's that? Okay, that's the main pass one. That's the first one that goes through, which has 300 volt stuff going through it the other side. So it could even be that. They're mounted on the back of the board, on the back of the heatsink just there. So that's also possible. It could be that one there, which is gone. So see, with that one there, that one there, and that one there, but this one here, say it's been replaced. It doesn't look original. I could be wrong, but yeah, it's in a socket too, actually. Looks awfully shiny. I'm trying to see if we can see numbers on it, which makes sense. It's like, it might be Fluke part numbers on it, so maybe it is original. But yeah, something's going on in this section here, so I need to try and figure out what. I might just do it by substitution, just go through replacing parts and replacing resistors and things like that, just to rule them out completely. You know, if I replace it, then it cannot be that. So yeah, it's something in here is wrong. Right, I believe that's what the issue is. Right, so I'm trying to diagnose this problem with the high voltage stage on here, and what I've decided is that well, I was just probing around. So it's got some Zener diodes in here, 10 volt Zeners, which I've tried replacing. just in case it's getting a bit weak. Didn't help. But what I've done is I've tied the multimeter here onto the TP6 test point, and if I test on these diodes when it's running, you'll see some interesting information here. So if I test on this diode here, which is the negative side, getting minus 10.3 volts, and on the positive side on that one I'm getting plus something, right? 9 volts or so, right? Get a better test point. It's jumping around slightly actually, it's interesting. But that's with it in the bias test mode. Now if I slide this over really carefully, being careful what I'm touching, put it back into normal mode, so I'm getting basically plus and minus 10 volts, which is what it should be doing, okay? On each end of those diodes. These Zeners are part of the, like a feedback circuit to control the transistor bases. So if I do this again, negative side first again, get a good point. I hope you can actually see that the camera not blocking it with my finger. Now I'm getting minus 50 volts on that one, which is wrong, and minus 28 on that one. So it should still be balanced. It's not sort of offset towards the bottom end. So that's kind of wrong. So yeah, actually, was I blocking the view? So have a look. See what was I blocking that view? Yeah, maybe. But anyway, so the whole range is shifting downwards to the negative side if it's in normal run mode. If it's in test mode, we've only got the I'll probably recoup that. We'll recover that. So in normal mode, it's got plus and minus 190 volts going on to each rail for this high voltage section. When it's in the test mode, it's got plus and minus 30 volts. So plus and minus 30 volts, it works absolutely fine. But plus and minus 190 volts, it doesn't work fine. So something's breaking down the higher voltage and dragging it downwards. So I'm trying to determine what is doing that. So I've replaced those Zeners because I thought that's an easy thing to change, you know. I've got a bunch of them, so just drop some new ones in. Nothing to do with those. I've done some resistance checks on various resistors and they all seem to be okay. There's one or two there I can't measure properly because of other circuitry around them. Not without popping them out. The other diodes in here are 1N4448, which is like a higher current version of the 1N4148, which is the common silicon diode. These are slightly higher current versions. I think they can do half an amp or something instead, 5 milliamps, you know, instead of 150 milliamps or something like that, I think it was, from memory. But the higher current versions of the standard 4148. So I've ordered some of those, and I'll just replace all those as well. Just do it, you know, just have done with it. The tantalums test okay. The voltage across tantalums test okay because they actually measure across the Zener diodes. There's across them to smooth out, obviously, spikes and stuff like that. That is rectification. So there's not a lot left in there for me to actually change. So I'm thinking it's probably a transistor problem, most likely, on this side. I just don't know which one yet. They measure okay, so it's obviously when it gets to the high voltage it's breaking down. So what I'm going to do is actually do some tests on these and try and determine which transistor is breaking down. I may be able to determine that from voltage measurements, but I don't know yet. I'll have to figure that out. Okay, so I think I might have come across a small issue here. Now, this is obviously the main board out of it, and sorry about the background noise. I've got the air conditioning on. It's really hot in here today. That's Q23 and that's Q20 there, right? In those locations. So that should be Q20, that should be Q23. Well, according to the number on this board here, this board is Q23, which should be here. I think someone's taken these out and swapped them over by mistake. I'm going to look up this part here and see what story is there, but it's supposed to be PNP and NPN, and they're back to front. I think. I'm going to do some testing. I was going to chuck a transistor tester on it, but it looks like they're actually been topped over, and someone's got that wrong. And this might be a pure fluke that it works when it's on the testing voltage of the plus or minus 30 volts. Okay, so I've got the transistors out. So this is like an array of transistors, which is like a later upgrade, I'm guessing, or replacement for original parts. And so you can see it on here, hopefully. 332, get it in picture shot. 332551. Now, according to the manual I've got here, that part, once I find it in the manual again, I've lost it. Q. One of these. That is supposed to be Q23. But it's not. That's in the Q20 position. So, but it is an NPN. I've just tested it with my component tester, and that's an NPN, not a PNP. So that is supposed to be in Q20. That's kind of confusing. Alright, so that is in the right place. The other part is a 2N6214. Okay. Now it's supposed to be a high voltage transistor. The specs look about right, I suppose, but when I put on my tester, it measures as a pair of diodes, not a transistor. So that's interesting. And this is the one I'm expecting is wrong. And this is a PNP part, and it's in the Q23 position, which is correct, well, for a PNP part. But this is the part I'm suspecting is wrong. And it's, in fact, it tests as diodes, means I think this is where the problem is. So I might have to look at getting another one of these parts.